Okay, great. So, hello everyone. Hope you are well. And again, thank you very much for your time and energy during solution of the first assignment. So today will be a second assignment after the lecture. And today we are going to discuss Numpy and Pandas libraries in Python. And firstly, let's remember what was in the last lecture. We were discussing Python language. It is easy, free, high level, and fun. And I am sure that now you know why is it fun, especially if you've solved all the tasks from the first assignment. So yeah, all the Python objects have ID, type, and value. And ID is something like physical address in computer memory. Then we've discussed that size of integer int type in Python is more than 24 bytes. It is amazing, but it is clear because of object structure of the language. And then in the last part of the lecture, we installed and a little bit used PyCharm for Python programming, for implementing programs in Python. Yeah. Okay, now let's go on to the Numpy library, and it named for numerical Python extensions. It is very important for us because a lot of real data stored in Numpy arrays, and the main goal of the library is working with multi-dimensional arrays or tables. So usually we use for table for two-dimensional array. And in Python, there is very quickly computations in terms of mathematical functions. And the core of NumPy package is NumPy numerical dimensional array object. You can see this link in the documentation. So NumPy ND array. And actually, it is very similar to C arrays if you know them, but it's not very important. So for us, it is very important that NumPy is very fast, and we will discuss it a little bit. And for us also is very important differences between NumPy arrays and usual standard Python sequences, or lists and tuples as you know. So the differences are NumPy array has a fixed length, and also NumPy array must be, so all the elements must be of the same type. Again, as in C language or C++ language, so you need to fix the length of array and the type of the elements. And after this, you can perform operations on NumPy arrays. So the speed of NumPy is due to, of course, implementation in C. This is the only way to make fast program, almost only, yeah. And the second feature of NumPy is vectorization and broadcasting, and we will discuss in detail what is it. Yeah. So let's go on to the ways of creating NumPy arrays. There are three ways of conversion from usual Python structures, as list, for example, generation using built-in functions, and of course reading from the disk. So the first way is conversion from Python structures. Here we import NumPy as NP. This is standard abbreviation for this import, and np.array here creates array of 5 elements. You see 5 integer elements, and the argument of this constructor is list, Python list, usual Python list. So the same 5 elements you see. And here after printing, you see the keyword array for NumPy arrays. Okay, so let's go on. If you want to specify the data type manually, of course you can do it either with argument dtype or directly from NumPy. So you see np.float32 means that here we create a NumPy array with float32 type of elements. And of course, these are different arrays. So the first one of integers, and the second one, and the third one of float32 type. Okay, and there are different other different types in dtype argument. You can read in documentation, but mostly all the C types are realized inside NumPy. Then the second way, you can generate NumPy arrays with commands very similar to usual Python commands. For example, arrange is analog of Python's range. So you need to specify the start, the end, and the step of your range, actually. And this is, but here arrange, you can use non-integer steps, not only integer. Then linspace and log space command, NumPy linspace and NumPy log space. These are ways to evenly divide a segment into n-1 intervals. So you specify the argument n and then get the array of evenly divided segment. Or this is the way to divide segment on a logarithmic scale. It means that you can you can use power to convert linspace to log space and vice versa. Then goes 3 usual commands: NumPy zeros, NumPy ones, and NumPy empty, which creates different arrays of the specified dimension. Let's see the example. So the NumPy arrange, with step 2. So you see we start with 0 and then add 2 and then add 2 again, and we get 0 to 4 because the end element is 5. So the next step, 4 plus 2 is 6, greater than 5. So we stop on the element 4. Okay, here we want to NumPy linspace between 0 and 5, and you see 11 borders. So the result will be 10 elements. You see n-1 from 0 to 5 with all the halves between them. Almost the same, but from 0 to 9 with 9 elements. You see this is 2 to the power of 0, then 2 to the power of 1, and then the last element is 2 to the power of 9. Yeah, because we get 9 elements, and this is the answer. Yeah, so all the float elements which are powers of 2. Then we can create. So here you see only one-dimensional arrays, and the next is three-dimensional array. So this is three-dimensional table matrix. You see this is the lists with 3 zeros in each, but there is first pair of of lists, and then goes second pair. So this is the table 2 by 2 by 3, and all the elements you see, there are 12 elements, are zeros. Yeah, so 12 zeros with some interesting shape, three-dimensional shape. And another one command, you can create two-dimensional array or matrix. So we will call usually two-dimensional array matrix. And this is diagonal matrix with first row as 1, 0, 0, the second row 0, 2, 0, and the third row 0, 0, 3. So the main diagonal of this two-dimensional array is 1, 2, 3. And you need to specify this main diagonal as argument of the diag command. Okay, so let's go on. All the Numpy arrays, they always have shape attribute and dim or number of dimensions argument. So you can see if we want to create, if we are creating Numpy ones with shape 2 times 3, so this is again two-dimensional array or matrix, then this is the shape 2 by 3, and the number of dimension is 2. So the number of dimension is always length of array or of shape array. So here we have 2 elements, and this is the number of dimensions for Numpy array. And yeah, there is a reshape method. So we can create one-dimensional array with a range, and then reshape it to the same 6 element, but to 2 matrix. You see the result. So this is one-dimensional array with numbers, integer numbers from 0 to 5, and reshaping gives us the two-dimensional array. So the first row is 0, 1, 2, and the second row is 3, 4, 5. Okay, so 2 rows and 3 columns in two-dimensional array. Great. Let's go on. Let's go on to the transposition or transpose operation. So here we create two-dimensional array with shape 10 times 2, and B is a transposition of A dot T. Let's firstly let me print A to show you, and here I want to comment yet. Okay, so the A, you see, it should be 10 rows and 2 columns with all 4 zeros, yeah, inside, all 4 zeros inside. Then, if we want to see the result of transposition, so let's print B array. It will be vice versa, 2 rows and 10 columns. This is transposition, so we simply reverse the order of dimensions in shape, yeah? And this is 2 times 10. So the elements will be the same, but in different order. And if we want to modify the shape without modifying the initial object, so here, let me, so B is A transpose, yeah, and here, let's print A just to see, yeah, so the A is 10 times 2, and B is new array. Okay, And view is modifying the again for modifying the shape of arrays, but you need to use a shape attribute with caution, because let me show you. So you cannot directly change the shape of C, despite the amount of elements is 20, yeah, 10 by 2. But if you want to directly change the shape attribute to the one-dimensional array to 20 elements, then you will get the attribute error exception, because Python don't want to and don't know how we want to reorder your elements to reshape it. So you need, and it says us, yeah, it hints us that you need to use reshape to make a copy, probably make a copy with desired shape. So let's do it. The same array A, yeah, you see it is 10 rows and 2 columns. And then we can change the shape of A without reshaping. Yeah. And this is kind of strange. We don't want to do it because we don't know how elements will be reordered inside this array. So much better to use either reshape command or some similar commands in Numpy. For example, you can use revel function to reshape your array to one-dimensional array. So let me show how to do it properly. So again, the first version is one-dimensional array with elements from 0 to 5. Then we reshape it to two-dimensional matrix, 2 times 3, yeah, and then revel this array back. So let me show that without this revel, we will get only two-dimensional matrix. So reshape is working, and please use this command to reshape your Numpy array if you want to do it. And of course, in the homework assignment, you will get into details of reshaping and changing your Numpy array and storing it in computer memory. Okay, and now we will discuss the indexation, both in Numpy and because of it is very similar to Python indexing, then let me show you what is going on. So the first array is again one-dimensional with from 0 to 5 with 6 integer numbers. Then we simply print the first element with index 0 and the last element. So these are negative index, and -1 means last element of your array or of your list in Python. The same syntax works in Python. Then you can print the intermediate elements. So from the first index to the last, but excluding last index. And you see from 1 to 4 without 0 and 5 elements of the array. This is syntax with comma, yeah? So again, from the first to the last, excluding last and including first element, first index of the array or Python list. Then you can use second comma to specify the step of your sequence. So again, from first index to the last index, excluding last, but with step 2. You see, we here we take first element and the fourth, yeah. So the element with value 3. So with step 2, you see the next element after 2 is 3, and we take only this one, so only 2 elements from out of 4. And very funny string, but it is okay in Python. So here you say with so-called slice that you want to take the very first element of the array, then you want to stop on the very last element, but with step -1. It means, so -1, it means you subtract -1 from the start, and Python understands that actually you want to start with the last element and then go to the first, so one by one. Of course, we can change this -1 to -2, so we can change the step of this slice, and we will get again last element, then number 3, and then number 1 without even elements starting from the end of the array. So yeah, and actually there are famous tasks in C, maybe you have heard about, reversing list. So in Python, it is simply one line because you can reverse list with this slice, Okay, let's go on. So with the 2 important notes. The first, that the main difference, okay, so the first is not, you need to understand how indexing works. So instead of using for 2-dimensional array matrix I and j in square brackets, you should use matrix I comma j, because this is so you need to specify exact element of the array. And here in this case, you firstly specify the row of your matrix, yeah? So the row number I, and you get it. And then inside this row, you specify the j index of the element. So inside Python, here you will perform 2 operations instead of 1. So that's why you should use matrix. This is better. And the second important note, that slices in Numpy always create views, not copies. And in case of standard Python, standard slices for list, tuples, and strings, the slices create copies. Okay, copies of your data. So you need to remember these two these 2 important notes to use slices either in Numpy or in native Python. Yeah, the structures of native Python. Okay, so let's go on. Actually, in Numpy, it's very convenient that you can use lists, Python lists, as indices. So this is the example. We again create the same array, 1-dimensional array with integer elements, and you see we ask with, you see, two more square brackets. So the argument of the index is list, and we ask Numpy to give us all the elements with indices 0, 2, and 4. And here is the indices and values are the same, yeah? So of course, if we change the elements, then you will see that this is the values of our 1-dimensional array. And the same, okay, let me return back to the 0, 5 integer elements. And so almost the same syntaxes, but here we specify a binary mask with the same length as the original one-dimensional array. Yeah, and this again it is very convenient. So we, yeah, why it doesn't work? Dimensions, okay, 5, 6, I see. Yeah, so they should be the same. So the length of your mask and the length of array should be the same. You see, this is the result. Here we take all the even elements of the original array. Okay, and let's go on to the shapes and values. So here you see two arrays, and firstly you can say that they are identical, but not. Here we create a NumPy array from list of list, yeah, and here second one, y, we create simply from list. So we know that y is one-dimensional array, yeah, and what is x? X is two-dimensional array. You see the shape of x is 1 times 3, okay? So for NumPy, x is one-dimensional vector. So this is column, okay? Column with elements, 3 elements, 1, 2, 3. And y is a usual one-dimensional array or row or, okay, or horizontal vector, yeah? So, and it has 3 elements. And that's why they are not equal, yeah? So the NumPy array equal command gives us false because they have different shapes. And if we want to get identical NumPy array, we need to add new kind of virtual axis to the Y array. So we want to add new axis to one-dimensional array, and then the shape becomes 1 times 3 as in X array, and this is okay. So for NumPy array equal, we get true because they are identical now. So they have the same shape and the same values inside this shape. Okay, so of course we can use masks and other interesting stuff for selecting different sequences of elements from the NumPy array. So you see here we create a one-dimensional array with integer elements from 0 to 9. Then we with one line again. So you see x divided over 2. So this is division with reminder, yeah, and we get only reminders. So for 2, it will be only 2 values, 0 or 1, and you see that we use this operation as x is simple number, but x is NumPy array, and the result will be actually binary mask. So for even values, we get 0, and for odd values, we get 1s. You see, and of course we can use this new array mask as index to filter the same one-dimensional array X. So here I want to choose all the elements of X which is divided over 2, so which is even, and yeah, which is greater than 5. You see the result. So this is the true answer. Yeah. So all the even elements greater than 5 are 6 and 8 from the first 10 integers. And we can even multiply. So this also works. So here we choose all the elements from X which are greater than 3, and then multiply all of them by 2. And you see the first, the first original array and the result of multiplication. Yeah. Well, and you see this operation changes the X values, the elements inside X. And here you see all the elements greater than 3, we multiply by 2. Okay, so this is really convenient for working with different Numpy arrays for images, for example. But yeah, and it is even possible to read comma-separated value file from disk with Numpy library, but better use Pandas for such a purpose. So because you see, we have the generation from text command in Numpy, and this is our comma-separated file, and we want to skip the first line of this file, and the delimiter is comma. So the result is, you see, the Numpy array with rows, and actually we can check the shape of this array as usual. So let's print data shape. Okay. So the shape is 5 by 4, and the values, you see different numbers, but of course it's difficult for Python to create and for Numpy to create Numpy array and to store all these types. You see some numbers similar to float, then some numbers similar to, you see, oh, this is all float numbers. Yeah, so let's check the type. Okay, how to check it? Let's maybe print type of data. Numpy and the array, and do we have something like the type? I don't know. Yeah. So the type of array is float 64. Great. And you see here nonce. It is not a number notation for inside float 64 object in Python. It means that in file we have, I don't know, some missing values or something else. Yeah, and or none as strings. Yeah, and Numpy convert these strings to none to none notation in float 64 type. Okay, and this is help for this function. So in model Numpy, and this is all the signature with flags. Yeah, so we can somehow specify the loading process, but again, better use Pandas for reading all the files to Pandas data structures, to Pandas data frame. We will discuss in the end of this lecture what is it and why do you need to use Pandas instead of Numpy. Then you want to read your data, your files into the computer memory. And now, before the break, let's discuss the broadcasting and vectorization operations. Actually, you've seen before that even for simple one-dimensional Numpy array, for example, for list, but Numpy list, yeah, Numpy array of ones, of 5 ones, we can use, so here you see this is the actual NumPy array with shape 5 and linspace, again, NumPy linspace with shape 5 again. So this is the result of subtraction. So this is L, it is similar to 1, so we can kind of subtract ones from each element of X, yeah? And the result is, you see, the result is 0, 1, 2, 3, 4, because we start with 1, and then let me print X for clarifying, yeah, what is going on. So this is X, then we subtract 1, and then we subtract, actually, you see here, we subtract something strange. We multiply one-dimensional NumPy array on the integer, yeah, on the integer number 2. And it is possible. So in NumPy, it understands that we probably we wanted to multiply each number in NumPy array on 2. And this is exactly what is going on. So we really multiply each number, each one in L on 2, and get and then subtract these arrays with the same shape from each other. Yeah. But actually, we can change this construction to simply 1 and 2. And NumPy will understand everything. So what we want to do, you see, the result is the same. So we can subtract number from array, and it means that NumPy broadcast everything and create for us. It will create new NumPy array, consists of ones here and consists of twos here, yeah? And then it subtract these arrays as usual. So the arrays with the same shape, of course, we know how to subtract them, yeah, element wise. So we subtract each element from each other. Okay, and this is broadcasting. So it works similarly for multi-dimensional arrays, and all the arithmetic operations, not only subtraction, but of course addition and multiplication too, performed element-wise in NumPy and performed element-wise in case of NumPy and integer or float numbers. Let's go on to how does it work. So actually, for this simple case, the broadcasting enlarge our one element, so it stretches to the same shape as n-dimensional array from NumPy. Then, if we want to broadcast, so here is again the example. We multiply NumPy array by 2. Yeah, this is the result. And if we want to, let me show firstly the example here is, if we want to broadcast two-dimensional array and one-dimensional array. You see here, the A is two-dimensional array, so matrix 4 by 3, and B is one-dimensional array, but the shape, if we look from the right, then the shape of B similar to A, yeah? So we actually need to add 1 here and then broadcast this row so then copy row 1 by 1 while we get the same shape as A. And then we again perform the component-wise operation. And the form of result will be the same as form A, and it will be 4 by 3, you see. And yes, it is working in Python. So here we create three-dimensional matrix or consists of ones with the shape 2 times 3 times 4. Yeah. And the shape of B, you see one-dimensional array, is 4, because B is integers starting from 1 and from 1 to 4. So the shape of B is 4. And here you see the result, A times B. Difficult operation, yeah? So the A, shape of A is, the A is 3-dimensional array, and B actually is 1-dimensional array. But we can, so starting from right, we see that, yeah, here is 4 and here is 4. Then we can add new dimensions to B. So this is 1, 1. And then we can broadcast it to the same shape as A, yeah? And then component-wise multiplication. You see, it works without any exceptions. And the rule is very simple. So we need to start from right, and all the dimensions along the axis must either be the same as here, 4 and 4, or one of them must be equal to 1. And we add ones if we need it. Okay? And this is how it works. But of course, we cannot use broadcasting if the shape starting from right will be mismatched. So here is the shape of B, one-dimensional B array is 4, and the right dimension of A is 3. So we cannot add these shapes in Numpy, and of course we will get an exception. Let me show you. So if here is different shape, then we get value error exception, and we see that operands couldn't be broadcast together with shapes 2, 3, 4, and only 3. Yeah, so this is mismatching of shapes. Okay, great. Yeah, and of course the here again the example of one-dimensional row, yeah, one-dimensional array. Then we can add new axis and transform this row to column, yeah. And this is the column you see here. Each element is one integer list inside the array. And here, let me add print to show you the difference more clear. Yeah. So this is the first array is row. The second array is column. You see here, row and column. And then, of course, their shapes are different. Yeah, and this is the example of adding the two arrays. The first one has the shape 4 by 1, and the second one has the shape, let me see. So it is 4 by 3, yeah, but we can broadcast 1, 2, so we can copy these column 4 times. Oh, no, not 4, 3 times. Yes, yeah? So we need to copy this column 3 times and add it element-wise to the matrix, to the second matrix, which has shape 3 by 4. No, sorry, 4 by 3. Yeah, 4 by 3. So 4 rows and 3 columns. And this is the result. 4 by 3 2-dimensional matrix. Let me print it. Print. Okay. And show you the result. Okay. This is broadcasting, and how does it work? Now let's have a break. Yeah, let's have a break. I don't know, for 10 minutes, and we will continue we will continue at 4:55. So yeah. Yeah, there is the slide with break. Yeah, there it is. Of course, you can ask something or write questions in Zoom chat. Okay, yeah, very good. Let's continue. And after discussing the element by element or element-wise operations, let's discuss matrix multiplication operation. Of course, it is in NumPy, but let's discuss the definition. So what is it? Yeah, what is the NumPy and matrix multiplication in NumPy dot operation? I will switch to the whiteboard screen, yeah, and we'll try to explain everything. So suppose, yeah, great. Suppose you have two lines on the plane, yeah, and you want to find the intersection point. So the equation of first line will be a1x plus b1y equals c1. Yeah, this is the first line, straight line equation, and the second line will be a2x plus b2y equals c2. So this is the system of two linear equations, and x and y are variables we want to find. So we want to determine the intersection point, yeah. And actually, these system of linear equations can be rewritten. So we want to rewrite the system in matrix form. In matrix form, it means that we will consider two-dimensional array or matrix, yeah, with A1, B1 in the first row and A2, B2 in the second row. Then we multiply these two-dimensional, actually 2 times 2 matrix on the vector of variables. So the vector x, y, again in NumPy, it will be a vector or array with shape 2 times 1, yeah, because this is vertical array, not horizontal one. So horizontal, the row will be would have shape 2, yeah, or 1 by 2, so 2, and this is 2 by 1, and the result is again the vector of C's, C1 and C2, yeah. So again 2 by 1 vector or two-dimensional matrix if you want, with shape 2 times 1. So you see here this this element and this element, they actually we get rid of them, and the shape of result is this 2 and this 1. So and how it goes. So you see we need to multiply. This is the definition of matrix multiplication. So here is matrix multiplication sign. In Python it is @ sign, but or NumPy dot. And how it works. So we need to take first row and to multiply it on the first column. Here we have only one column, yeah? So first row on first column, and this is dot product of one-dimensional arrays. So you see element-wise A1 times X and B1 times Y. And this is our result. So the first element of resulting array will be C1 or this combination, yeah? And then we go to the second row and multiply it the same way, this is matrix multiplication. So we multiply second row on the first column, and here we have only one column, and the result is C2. So this is equivalent, the same, yeah, as this is simple linear algebraic form, and this is matrix form. And of course, you can enlarge your system. For example, you can consider three planes, two-dimensional planes in three-dimensional space. Yeah, and the same way you will get a 3x3 matrix with multiplied, so dot product it on the vector of variables, again three-dimensional vector, yeah, x, y, z, and this is 3x1 shape, and the result will have, so again we get rid of these threes, and the result will be 3x1 with a, b, c, d, with d's, yeah, d1, d2, d3. Again, three equations of two-dimensional planes to intersect them, yeah. So if we want to intersect three-dimensional planes in three-dimensional space, and so on. Of course, you can consider different matrices for different problems and for different systems of linear solutions, but dot product will be the same. And you can use either @ sign in Python. So this is matmul, matrix multiplication operation, or numpy dot, and this is the same operation, numpy dot, as you see here. This is it. And we've seen transposition. So transposition, it's much more easier when you simply reverse the shape. So if you have matrix A with the shape I don't know 3x2, then A transposed will have shape 2x3, and actually you simply reverse the order of all of your axes for the matrix. Yeah, let me then show it on some examples. So I will return back to the slides. Yeah, and we will continue. Great. So this is the yeah, this is the numpy dot and transpose operations, and yeah, there are of course some function for aggregation elements. They are numpy min, max, sum, mean, and so on, standard deviation. So for yeah, great. So for the transposition, you see we create three-dimensional array with shape 4, 1, and 5, and with 20 elements here. And then we transpose it and print and we print shape of transposition. Okay, maybe let me change a little bit. So let's consider 10 elements with 10 elements, 2x1x5, and let's print not only shape but the actual result of transposition. Yeah, this is it. So the first three-dimensional array is almost you see it is almost two-dimensional, because here we have only one as some kind of virtual axis, yeah, virtual dimension. And let's get rid of this to see the actual matrices, yes, or two-dimensional arrays. So here we have 2 rows and 5 columns, and with transposition, in transposition we have vice versa, 5 rows and 2 columns. But the elements are the same, and the shape is simply reversed. Okay, so this is the example of transposition operation. If you want to reshape, I don't know, let's make something like 24 2 by 3 by 4. Yeah, so this is it also works. So this is the first 3-dimensional array, and then after transposition you see changing in rows and yeah, rows, columns, and so on, because in 3-dimensional we have third direction. Yeah, we have depth, and we'll also discuss it. Okay, so for aggregation operation, it's really easy. Or if you have, let's return back to to 10 elements. Yeah, so 2 by 5. This is it, and then we calculate the mean of all the 10 elements. So sum of them divided over 10, divided over amount. Of course, we can calculate mean and by axis. So this is mean by the first dimension. So axis equals 0, and you see the shape was 2 by 5, and the result is 5 because we get rid of first dimension. We get rid of 2. And the result is mean values for each of column. So for each column, because we get rid of first dimension, yeah, and we leave second dimension, which is 5. Vice versa, we can calculate mean elements by by rows. You see here each of this element is mean value for the first row and for the second row. And here we can calculate mean for whole elements. And here is if we have more than 2 dimensions, then of course we can choose 2 of them, any 2 of them, to calculate mean value. And the same for sum, for min and max, and for standard deviation too, for any aggregation function. Okay. Now, so let's return to, yeah, this is okay. Operations, casting, and yeah, very good. So let's discuss the concatenation of multidimensional arrays. So suppose you have, let me show, okay. Suppose you have several arrays and you want to somehow stack them, yeah? The really good example for understanding is so-called 4-dimensional point. So you see this is actually one number, integer number 1, but we reshape it to the 4-dimensional array. And you see the result. This is so list of zeros, but actually it will be 4-dimensional point in Numpy, yeah? And here we stack 2 points on different dimensions. So you see, vertical stack is stacking on the very first dimension. So instead of first one, we get two. Horizontal stack, H stack, is stacking on the second dimension, or so the first is row dimension for matrices, the second is column dimension, and then the third is depth stack, so D stack. You see, this is third dimension, and that's it. So if you want to stack our four-dimensional points on other axis, we need to specify it, and the shape of concatenation of 2 points on axis 3 will be 1, 1, 1, 2. You see, yeah. Okay, sorry. So of course, if you want to use only concatenate operations, then we can specify axis 0 for this stack, axis 1 for H stack, and also axis 3 for axis 2 for D stack. The result, you see, results are the same. Okay, so this is stacking of two different arrays. And yeah, this is it about Numpy. Now let's discuss second library, which is Pandas, and it named from panel data. So the main purpose of Pandas is naming your rows and columns. So in NumPy, you have only numbers. So your multidimensional arrays are simply numbers with indexes, and it is, frankly speaking, it's not very convenient for using. So you need to remember the numbers, and this is so mathematical point of view, it's really difficult. So people love names, and so that's why Pandas is better than you are working with real data. So you can title your columns, and they will be features of your objects in the future. And these titles should of course reflect the physical meaning and so on. And actually, you can also title the row. So there is row labels in Pandas. Yeah, and they also is not necessarily numerical. It is very convenient, but Pandas built on the top of NumPy. So the same operations, the same syntaxes, the same slices, and so on. So let me show here. Oh, yeah, here is typos. And I read the Titanic dataset to the Pandas data frame. So this is df Pandas data frame. Let me show you the result. So you see the first first three rows of the dataset. And you see your data now, it is very convenient even to print them. So we see passengers IDs, derived or not, or classes, and other features, including string, float, integers, and so on. So this is your data. You can understand what is going on. It is really one line in Pandas, but not in NumPy. So in NumPy, you simply have some objects here, and there is no such nice presentations. And there are a lot of useful commands inside data frame class. So you see, I choose again almost as in NumPy, but I identify the columns by title, by their names. You see, I choose sex and cabin columns, and then describe them with one command. So I see the number of elements. So no, no. So yeah, then elements with values, the unique amounts, and so on and so on. So the most popular, the and other information. Even better, I can use both slices and other commands. So you see in data frames here I sort values for the age column, and I do it in place data frame. Yeah. Then I print the row number 78. And this is the command ilog integer location command. So it's this is the command like like NumPy. Yeah. So if I want to print the and if I want to use indexes of the integer indexes of the data frame, I can do it. I can do it with ilog command. Then so log command gives me the so here is index 78. So the name of rows are almost the same as numbers of rows, because we here in this data set, let me show you again. Here you see this is index. So in this data set, we don't use labels for rows. But we can choose one column and make index from it. For example, passenger ID. Yeah, this is the good candidate for the indexation of these data. Okay. Then of course I can choose rows by indices and columns by titles. And this is again part of my data. So on the 2 columns and 3 rows, and you see the view of data frame. Okay, very convenient. So log location command and then 2 lists. Okay, for rows and for columns. Yeah, and this is important. So if you want to modify the data of slice, of course you need to make a copy. You see here copy, because again log command will give you a view, and if you change it, then you will change the original data in your data set, in your data frame. Okay, and of course if you copy the result, then it is working okay, and you can change for example age here and without changing the original data. Okay, and if you want to change the main table, then you simply select some slice. For example, again, very nice syntax here. So the age of passengers is in 3 values in this list, yeah? And then we select these passengers and with some slice. And also, so this is the condition, and this is another column there, and we multiply the there by 1,000. We change only these slice inside data, inside our data. Okay. And if you want, yeah, to do it like this with slice, then Python gives you, Pandas gives you the so-called setting with copy warning. So it means that we are trying to set value on a copy of slice from data frame, and it hint us, yeah. So use log instead, as in first example. Okay. So Pandas is very convenient wrapper for NumPy. you can get values on the necessary columns with the same slices, but using either indexes or column names. Then, yeah, there are a special name for one-dimensional data frame, and it is series. So Pandas series, it means sequence one-dimensional data frame in essence. And you even can get, if you want, you can get a Numpy array which lies inside Pandas data frame. So this is the values field of data frame. And series are almost the same as data frame, you see. So if you select only one column, then you will get series, but it has the same head command as data frame. And this is first five element of the age, and you see name, the type. So the difference of series and one-dimensional Numpy array is here. It has name. So in Pandas series has name, for example, age here. And if you want to select data as data frame, so you don't here you select the same data, but as part of data frame. You see, I add square brackets, and here you see the title column and the row indexes of the data frame. This is the difference. And of course, you can convert series to data frame. Yeah, this with .toFrame command. Yeah, and of course you can get values which will be Numpy internal Numpy array from data frame or series. Okay, and maybe the last point. So how to make concatenation for data frames in Pandas. Firstly, we select some different columns from original data frame. Then we can join. So there are two operations: join and merge. Two commands in Pandas: join and merge. And you see here, join means concatenation by index. So both data frame 1 and data frame 2 has the same index, and we simply add two columns from one data frame, from data frame 2 to the first data frame, but based on the indexes of these rows. Also, we can join by some column. So this is merge command, and when we perform Pandas merge with the same data, but on passenger's ID, you see. And do we have passenger ID? Yeah, data frame. Okay. Because yeah, so here we need, of course, to specify passenger ID, and the result is again joining row by row, but based on the same passenger ID. And so in essence, the difference between merge and join is this one. So merge usually works on columns by default, yeah, and join works on indices by default. Merge is more flexible, but join is primarily designed for index-based and usually faster. So you need to use join when you want to effectively and fast join data frames on their indices. But if you use columns and you need to use some convenient operation, then merge is okay. So it is like like SQL like joins for in merge command, and you can actually merge as in SQL you can merge. So there are 4 types, inner join, outer join, left and right, and the same specifications are for merge in Pandas. Okay, so this is almost it. This similar commands in Pandas, there are similar commands to SQL syntax. So here we calculate, you see the meaning age for passengers of first class, then passengers of second class, and passengers for third class. And here you see we really quickly check the hypothesis that higher class consists of elder passengers. You see, so the average age is increasing. And of course, we can calculate the same result with group by operator. So we firstly group by our data frame by the passenger class, and then select the age column and calculate mean. So the result is data frame with column age and index the class 1, 2, 3. Okay, then of course we can group by other columns here and even count the number of passengers in survived in each class. So this is the result. So number of passengers survived in each class. Okay, and again the survived passengers in each class, but with cabin identifier. So this is the, you see, a little bit detailed picture, not only passengers but with cabin number. Okay, so the last slide is 10 things McKinney hate about Pandas. And it is useful to read to understand the limits and the restrictions, but you see the author and the author worked for Amazon here, and the patch arrow, it is the concurrent package, so similar to Pandas but not. And of course any package, any library has some limitations, and you need to understand but Numpy and Pandas are the most popular, and firstly you need to understand them to switch to other similar structures in Python. So that's why the current homework will be about Numpy, and next homework will be about Pandas, and you will get good experience using all the methods and the structures and the attributes inside these packages. And then in machine learning, of course, we will use both Pandas for data analysis and Numpy for storing almost everything. So, and also the tensor structure from PyTorch or from TensorFlow are very similar to NumPy arrays. So firstly, you need to understand them and then easily switch to tensors for storing and training neural networks, for example. Okay, so let's stop here. If you have any questions, please ask here in Zoom or in chat. Okay. What is the next lecture? So the next lecture will be introduction to machine learning. So we will discuss mathematical statement of the problem and metrics. So metrics of object and features. And then we will discuss different loss functions and simple model, simple linear regression model. Okay, great. So thank you very much. So you, of course, can write any of your questions in our Discord chat. Yeah. So, and the record will be available just now because we have stream on YouTube. Okay, great. Let me stop share and